Okay. Now, what's going to happen right now is I'm going to print something off for you. We'll assume that's okay. 3, 4, 8, 12, so 15 of them.
That's 45.
That's 45.
Oh, hey. All right, we don't need that many. And we're on C221. I think we're all right. We're good.
I don't need one, but if you just want to make an extra.
Okay, so we'll back that off to 13. Up to 13. This is a correction from what's on the website.
Is it?
Sure is.
Oh, but I do need one.
Well, I'll post it.
See, I was being good and I did all this at the beginning of the class.
Yeah.
Really waste your paper
But it's
when
wrong.
it's already here.
Now, I was going to say extra credit if you find out where it's from, but extra happiness if you find out where it's from. So, no, you're not going to use this for the exam, but it is helpful.
Did you get
Joseph, you want to hand those to the rest of the
Extra
class?
paper printed, so I'm just trying to separate it.
Extra paper printed?
Yeah, so printed in a blank
Oh,
page.
man.
So I'm just trying to save paper.
All right, way to go. Extra for Joseph. The trees
Extra happiness.
will vote for you.
I'm going to do that.
Everybody vote for me for Steve Money President.
No, sorry. Trees don't vote for Steve by Christmas. But if you're out in the middle of the forest and you're lost, say, "Oh, great trees, I saved some of you from destruction." And that'll help you out right there. It'll move aside for you now. All right. So what we have here then is a description of the different types of hypothesis testing, which is what we just did. So let's download this as a PDF perhaps. There's got to be a way to make that happen.
Thank you. I don't have one. Oh.
Yeah, I guess. There. And so then we have these 6 different types of hypothesis testing, 3 of which we've already done today, 3 of which came from previous assignment. Why did they make me sign up 3 times for the same thing? I already signed up once to access the program. I signed up again in order to use it offline, which I didn't mean to. And now I'm signing up again in order to save it as a PDF, but there's no reason for me to have to do that. That's what you get with Microsoft.
That's it.
Nah, no. Bill Gates. All right. So we have these 3 different situations where we have just a single sample. One where we're talking about averages, another where we're talking about proportion, another where we're talking about standard deviation. Okay. Then we have what we did today. Difference of 2 averages, matched pairs examples, and the 2 proportions. So these are all things that we did today. And since it was wrong out there in cyberspace, I figured I better correct it and give you the correct stuff. right away. We also have on Blackboard, if we were to go there, under the notes, we have confidence intervals. Okay? So these are the types of problems that we have when we're talking about confidence intervals. Sample size calculation. I need to revise this one too, I guess. Because we're not going to do for the mean, we're just going to use proportion. Then we have confidence interval for the mean, confidence interval for proportion, confidence interval for standard deviation. These formulas are all given to you on your laminated sheets, and these formulas will all be given to you on the test. So you don't have to memorize any formulas. They're all given to you.
Are they going to be labeled on the test? Or
They will be. They will also be labeled on the test.
Perfect.
Okay? It'll look just like what's on your sheet. Okay?
Oh.
All right. So, in addition to that, which we've just talked about, I also have a practice test, number 3, for introductory statistics from different things that are out there in the textbook and a couple of other little thought questions and all the answers are listed there. Okay? So my plan is we're going to do this on Friday. Okay? This is not something you have to turn in, it's just something to practice, and then we'll go through it. We'll do that on Friday. So today we'll just kind of do some examples. We'll focus our attention on finding confidence intervals. Since we already spent an hour or more with hypothesis testing, we need to do some work with confidence intervals. So we'll do that now, then we'll come back on Friday, we'll do this practice test, and then the actual test is a week from today on Wednesday. All right? Any questions about that schedule?
Are we allowed to use the Excel?
No, you don't need Excel. No, you don't need
To
Excel.
calculate the
You will not have to calculate any standard deviations. But you will have to use your calculator to do things like this. All right? So, let's start with a proportion. Yeah, well, let's just do one that we already did just recently. We'll go with those airplanes. So we had airplanes, and we had 213 out of 300. Time. Out of 300. And I want a 95% confidence interval for the proportion. Okay? So, I'm going to give you a couple minutes so you can come up with that. 95% confidence interval for the proportion. Given 213 out of 300, we're actually on time. Oh, yeah. Sorry.
Yeah. Right? Okay, I'm just gonna try what I have here.
All right, check with your neighbors, see if your neighbor's on the right track here.
Hold on.
You are, I know.
We don't need to start, we're trying to figure out the equation. Don't do that. It comes so far, a month past.
Yeah, I know, but I'm gonna fail it when I bring back the GPA, and I have to count it last week in order for it to be official. When I look up to the counselor, I don't want my GPA to be affected, and I'm not going to a 4-year school this year. So I guess I was gonna be here. I'm at a 3.1 GPA, and I want to graduate with a 3.1. Which is more important to me, I think. Having to read the class, that would be my bachelor's.
I get you.
Whatever. Hi. This class is really fucking hard.
Oh my God, Jenny, she doesn't mean it.
I really do. Good teacher, though. Hard class.
Oh my God. Maybe they're gonna be old, that's the thing, and I got it.
Maybe we can use the...
Oh, I know that. I know. I'm not backward. Wait.
One pair.
No. That's why. And it's 300.
Even similar, even,
Yeah, that's what I did.
this is yellow, green, blue, pink for the men, and pink for the men. For the side, eight. You get this, Jenny?
I don't know yet. I have faith in you. I'm done.
All right, so Katie, it's now correct, the one that's online. So if you,
What?
all right, so we're doing confidence intervals for the proportion. What's the formula that we need?
P hat minus, Z, D divided by Z.
Alpha.
Little d.
No.
What is that?
Is there an alpha in there?
What comes after Z in the formula? No, sorry.
Isn't it alpha over Z?
Alpha
two.
over 2.
Oh, that's a 2, not a Z. Okay.
Okay.
Why did I get that
That's important. Confidence intervals are always two-tailed.
Okay, no, that's an alpha.
So we need to have the alpha on both sides,
Oh, wait, no.
divided by 2.
I'm gonna go far back.
What comes after the alpha over 2 then? Okay.
I got the problem right.
Okay. What's p hat?
P hat was
2.71.
0.74.
0.74. I got
I mean, sorry,
0.71.
0.71. All right. Ooh, okay, yeah. Just testing you there. Sure, yeah. What's Q hat?
0.29.
What's M?
300.
What's the Z of alpha over 2 in this situation?
1.96.
1.96. There you go.
I can't remember what people
So 0.658.
So then when we actually put the numbers in there, confidence interval calculator for proportions. And we go with sample size of 300, 71%, 71, right?
Yes.
So it's 66% to 76%. Or
Can we
plus
have
or
our
minus
fans?
5.13, so 66.
24.
Okay, this is 1.96 times the square root of 0.71 times 0.29 over 300. So this is 0.513, 0.71 plus that, and also minus that. Okay, any other questions about that process right there?
The Z alpha divided by 2, you don't really divide by 2, right? You just use the 1.96.
Okay, when we say what is Z of alpha divided by 2, this is the Z, okay? This alpha divided by 2 is a label on the Z. We're not dividing anything by 2 here. We're just labeling the Z to find out what Z is.
Oh, wait.
Okay? So then when I say, where do I look for this?
Table F.
This one.
Okay, we look at table F. We're looking at confidence intervals.
So it's on the bottom.
95% go all the way down to the bottom. Notice that it says two-tailed, right? The alpha would be 0.05. If it were one-tailed, it would be 0.25, right?
Yeah.
Where's my sheet? So it's not a matter of actually dividing anything by 2, it's a label that we put on it, which is 1.96.
Okay, so did you round down to 76%? So I got 70 or 0.7613.
Okay, when we say 0.7613, we want to know what's the nearest percent?
All right, I thought you were
76.
gonna go up.
Sure enough. Nope.
Just in case. You
Nope.
know. All right.
That's for sample size calculation.
Oh, okay.
Okay? All right, any other question about this confidence interval then? What does it actually tell us? What's the purpose of the confidence interval? Oh, Fritz.
When I keep plugging in my calculator, it keeps giving me 0.05
Okay, 0.71 times 0.29 divided by 3. Okay, there we go. All right, so what's the purpose of the confidence interval? Okay, to measure something about a population with a specific amount of confidence. It's good for you to know that, all right? So what we're measuring right here is the on-time performance of this particular airline. With 95% confidence, we know the population proportion of on-time arrivals is between 66 and 76%. Okay. So that's population proportion confidence interval. Let's do another one.
The confidence interval.
So let's back up to one of these other ones we did. 92. So let's say that people who gamble on slot machines, slot people, they have a mean age of 48.7 years. Standard deviation is 6.8, and this is for 25 people. I want the 90% confidence interval for the mean. Start there.
So, because we don't have an air so yeah. So, now. Yeah, because we have this unit. Oh, it's this. Help us.
No. Is it this one that I need to be doing?
Is it that one? No.
No. Oh, see. Good guess. Look at them all. I'm seeing. What if you like talk to them?
You can talk to the bunny. Play with
That's weird. I feel like he should be talking kids. I don't know. Santa Claus talk.
Yeah. No, you're right.
That's for sure.
Because if not, it wouldn't make sense.
I don't know. I think it would be crazy.
I don't know.
Giant bunny that just like I don't see how I can adjust.
Yeah.
in the paper.
I wonder if I can like like that. Abby sucks. Why are they recording?
Because for the conference.
So they're all gonna do that comment. Sorry guys.
All right, so yeah, check with your neighbors, see what your neighbors got going on.
All of the information right now. What do you get? We have the information.
We don't know
right
what
now.
Cleveland's you.
Oh, okay. Sorry.
Sorry, overachiever you are.
That's
Yeah.
So it's opening Internet Explorer. That's where that's going.
So I do have
And 24
Good. So, how do we figure out T?
You then have to graph.
Degrees of freedom.
Yeah.
Oh, so now we have 24.
Okay, Joseph, what's our formula for confidence interval for the mean?
Yeah, to be honest, I am
I know.
Okay,
not. I'm somewhere else.
somewhere
I
else.
think,
Right,
right?
Danielle?
Is it the x bar minus t alpha over 2, and then in parentheses s over square root of n?
Yes, it is. And then
And
we
then-
have mu there, and then
and
we
then
have plus
repeat.
sign. Okay, that's correct.
Okay.
Now, what t-score are we going to use?
Yeah, that's confusing.
Jacob, can you tell me what t-score I'm going to use?
I used 1.711,
Where'd you get it?
table F, under 24 degrees of freedom.
So it's 24 degrees.
Okay. 90% confidence interval. 24 degrees of freedom, 1.711. It's right there. This would be 6.8 on top, 25, square root 25 on the bottom. And this is 48.7 plus, and then, sorry, minus and also plus. So, go out here and look for confidence limits for mean calculator. 90%, 25, mean 48.7, standard deviation 6.8. Very calculated. 46.4 to 51.0.
What did you get for?
So I got like 25. 51, right? Yeah. See, it's once I figured out the equation.
Yeah, that works.
All right. Any question about this calculation so far?
Sure, that's my.
Now, what I'm going to tell you is something that I tell the 200 level course. We do a lot of work on this, but we're just going to talk about it right now. It's not on the test, just so you understand. This is the confidence interval telling us where we think the average is for the people that play the slot machine. It's between here and here. So if we did another confidence interval for the people that were playing roulette, which we said was 55.3 here, sample size was 35, and standard deviation was 3.2. Calculate that, we get 54.4 to 56.2. These are the people who play roulette. This confidence interval here is for the people playing slot machines. This confidence interval is people playing roulette. What would you say if you look at these two confidence intervals? Okay, there's no overlap. What does that mean?
It just be volatile.
If you're 51
And that's all.
or younger, you're going to play slots. If you're 54 or older, you're going to play roulette.
Okay. There's a difference in ages between these two then. The people here are definitely younger than the people over here because these people are going to be less than 51 years of age. These people are going to be older than 54. So therefore there is a distinction between these two based on the confidence intervals. This is the, shall we say, more fashionable way to do research now. Instead of going through and doing hypothesis testing and doing all the processes that we've done recently, people will say, well, let's just make a confidence interval for each of these numbers. And then we can look at the confidence intervals and we can see if there's a difference. Because this clearly is lower than that, so then therefore these people are younger. And that's how we would make the decision. However, the more traditional way of doing it, using the techniques for the other chapter, actually tends to work more often than this does.
So would that be like a reason to do a hypothesis test? Like you see that the two age groups are different, so then you could...
Right, yes, you could certainly make that work, yeah. So that you see that there's a difference, so you say, well, let's see if I can actually prove using a hypothesis test that they are really different. Yes, that would be reasonable. The fact is, again, that a hypothesis test will give you more clear results. It'll work more often than this would. So even if there was a little bit of overlap, you might still try a hypothesis test. Okay. All right, so that's hypothesis testing for the mean. Now we're going to do a hypothesis test for the standard deviation. so I want a 90% confidence interval for the standard deviation. And in the interest of time, we'll just go through this. So, April, can you tell me what is the formula for standard deviation for a standard, or sorry, can you give me the formula for confidence interval for a standard deviation?
Square root n minus 1 s squared over divided by chi squared, right?
Okay, and then on the other side, same thing with chi squared left. So we're trying to figure out the standard deviation of the ages of people playing slots. Now it's hopefully clear to you that n minus 1 would be 24. S is 6.8. So I have 24 times 6.8 squared on this side and on this side. But I need my chi-squared values on the left and on the right. That's where the thing gets, pardon the expression, dicey. See, roulette, dicey, it's gambling. Slots, gambling, dice. Okay. So I need chi-squared. So where am I going to look on chi-squared?
Table G.
Table G. Where on table G
Oh, yeah.
am I going to look?
At 24 and
Okay, I have 24 degrees of freedom. What else?
0.90,
No.
0.10.
No.
Okay.
Why would I look in 0.05?
Oh, because it's
divided by
Eli.
2.
Okay, so I have alpha divided by 2, which means I'm going to have 0.05 on this side. Okay, so if I look up 0.05 with 24 degrees of freedom, what do I get? Okay, and where do I put that? Left. Okay, that's chi-squared right, so I put it on the left. 36.415. Okay. Now what else do I need? Lee, can you tell me what else I need?
Me?
Yes.
You have to find the one for the left.
Okay, so which one am I going to look for?
For that, you take 1 minus 0.05, so that's
Okay.
0.95.
All right.
Even though it's 24, that's 13.84.
13.848, that's correct. So I take alpha divided by 2 is 0.05. That gives me what's over here on the right. But over here, it's 1 minus alpha over 2, or 0.95. Tell me that number, which is this right here. So now we need to do that calculation, find out what numbers we're going to get. Now, I'm not sure if I have a calculator for this. Interval for standard deviation. There we go. standard deviation of 6.8
Oh, I didn't do this for
in is 0.5.
Is it 5.52 and 8.95?
5.52 to 8.95. Yes, it is. Okay, that's
Second calculation.
Now, here comes the question. What is this actually telling us? What are we actually measuring when we're talking about the standard deviation of the ages of these people? What does the standard deviation actually measure?
Variance of the mean.
Somewhat, but not exactly. All right. What is the definition of a standard deviation? What does it do?
It measures how rapid, how long
I'm sorry, what did you say? You're still thinking about it, okay.
Well, I need to know what it is.
Yeah, you understand it. That's it.
Like how something spreads.
Okay, how much the data is spread out from the mean, okay? Or the variation of the data from the mean. You missed that little phrase right there. Okay. So we look at this and we say, these people, they have a particular average, about 50 years old, but how spread out is that? Well, the standard deviation is the way to measure that. So you need to understand what that's talking about. All right. Good enough? Sarah, I suppose you can press that button for me, and then I can go back there and try and figure out what's going on. Go from there.